Welcome to the lecture 10.1 of Digital Electronics. In lecture 10 we have dealt with ASCII code. In this lecture we will be dealing with error detection code. In that we will be dealing only with parity method. In parity method we will be dealing with only odd parity and even parity. Only that much is specified in the syllabus. So coming into error detection code. Coming into error detection code. Parity method. So to have an introduction about why we are using error detection codes. Suppose assume that you are having a sender part for information transmitting. You are having a sender part and a receiver part. Okay. So information will be passed from sender to receiver. Okay. Now here what happens, and that information is again in binary format. That information is again in binary format. Now, if during transmission or during this information passage, transmission, there is a chance for distortion of the digital data or the binary data. Now why this distortion occurs? This distortion occurs due to noise and disturbance in the circuit. Noise and disturbance. Okay. Now if due to this noise and disturbance, for example, you are transmitting the binary information in 0110 form, something happens in such a way that this may be changed to, this is the central part, and due to this noise and disturbance in the receiver part, we have received like this 001 100. So here what happens, this is the data sent by the sender and this is the data received by the receiver. So what happens, these one and 2 are entirely different data. So what happens, the perception by the receiver will be different. So to avoid such kind of errors, we are going for error detecting codes. Okay. So in error detecting codes, how to determine an error? How to determine an error is determined by is done by parity method. Okay, that means sender sends some data and a receiver receives the data, and if there is error with respect to the data sent by the receiver, with respect to data sent by the sender, then it can be checked in the receiver side. Okay. So that is why we are going for error detecting codes. So coming into the parity method of error detection. Parity method of error detection. Okay. So here there are two steps. First one, add a parity bit which is add a non-parity bit. That is from the sender side. Second step, in that there are two types of parity. You can add two types of parity. That is odd parity and even parity. Okay. Now for odd parity, the parity bit is set to 1 or 0. It is set to 1 or 0. Now, at the receiver end, when the data is received, count the number of ones, number of one bits, including parity. Again, if that number is odd, then you can say that no error is there. Whereas if that number is even, then we can say that error is there. That is known as odd parity. Now coming into even parity. Here the parity bit added is 1 or 0. Added is 1 or 0. Now at the receiver side, count number of ones in the received data. Number of one bits in the received data. If that number is even, received data including the parity bit. Now if that number is even, then we can say that data contains no error. Whereas if that number is odd, then you can say that data contains error. Okay. So I think you have understood what is meant by odd parity and even parity. So here there is a parity bit. That parity bit is set as 1 or 0, and the entire data is sent to the receiver. And at the receiver side, you count 1 bit in the receiver side. And if it is odd parity, and if number of that 1 bit is odd, then that means it is no error. And if it is even, that is error. Whereas if you are checking for even parity, it is you should interchange even and odd. That is the only difference. Now coming into some checking part using some examples. So I am having a question. Check which number contains error using even parity method. Okay. So there are 3 data. First data is 1010 1010. That is first one. Second data is 1111 0110. Third data is 10111 001. See here, the question given is these all are the data which is received in the receiver side. That means this already includes a parity bit. Okay, this already includes a parity bit. No need to add separate parity bit. So what is even parity method? In even parity method, count number of bits with value 1. And if that is even, there is no error. Whereas if it is, or if that count is odd, then we can say that the given data is errorful. So here, how many ones are there? 1, 2, 3 and 4. There are 4 ones. Therefore it is even in number. That means it is no error. Here, how many ones are there? 1, 2, 3, 4, 5 and 6. 6 ones are there. So it is an even number. So it is also no error. Here 1, 2, 3, 4, 5. There is only 5 ones. So 5 is an odd number. So it is having error. that is having error. Okay, so that is regarding even parity. Another example I will do with help of odd parity. Odd parity. So the question is, using odd parity scheme, using odd parity scheme, find which word contains error. So first question is 10 11 0 111. Second question is 100 11 010. See, that is 111 111 010 010 10. Okay. So here, how will you count odd parity? You count number of ones in the receiver side. This is the data which is received in the receiver side. You count number of ones. This here 1, 2, 3, 4, 5, 6. There are 6 ones. So here what happens? Here the number is even. Therefore, that means number of ones is even. Therefore, you can say that data is having an error. Again, here 1, 2, 3, 4. It is 4. 4 ones. That means this 4 is an even number. According to odd parity, you should have odd numbers. So if it is even, means that data is also errorful. Here 1, 2, 3, 4, 5. That means there are 5 ones. That is odd. Therefore, that is the only data which is having no error. Okay. Hope you have understood the parity method. Okay. So in this lecture we have dealt with parity method and introduction to parity method and what is the necessity of error detection. Okay. So we have done with odd parity method as well as even parity method. Okay. So with this lecture I am ending with the coding. So in coding we have dealt with alphanumeric codes and numeric codes. In numeric codes we have dealt with the BCD, gray code and access tree code. In alphanumeric code we have dealt with ASCII code. And in error detecting code we have dealt with odd parity and even parity. So in the now I am stopping some portion of first module here, and I am going into the logic gates. Logic gates is also in module 1. So in the next lecture we will be dealing with an introduction to logic gates and how these logic gates can be realized using resistor logic and transistor logic if possible. Okay, that will be dealt in the next lecture. Thank you.